Alright, this is for the thermistor. Here, this defines the thermistor pin. These right here are for converting resistance to temperature. This defines the LED, and this is for the motor driver. Right here, I'm just setting up the pins, outputs, and right here to start, motor's off. This is the voltage. R2 is the resistance in the thermistor, across the thermistor. R1 is the resistance of the resistor. You want it to be around the same as the thermistor. This right here is the Steinhart equation. It relates the resistance to temperature. This converts the temperature from Kelvin to Celsius, and this converts it to Fahrenheit. This prints the resistance, and this prints the temperature. And this is if the temperature gets above 72 Fahrenheit, then enable high. That turns the motor driver on, direction A, motor forward, and the LED set to high. For the circuit, I got the LED hooked up to pin 8 with a 220 ohm resistor. The thermistor is hooked up to a 10,000 ohm resistor. It's a 5 volt power and ground, and the blue wire is going to analog pin 0. The motor driver is hooked up to the power module, so I'm not running off the 5 volts of the board. And if I warm up the thermistor with my fingers, LED comes on, the fan comes on. You can see as the temperature gets higher, the resistance goes down. When the temperature drops, the resistance rises. Okay, for the joystick, we include LED control for the matrix and the servo library. You set your servo. This is for the joystick, analog pin 0. The button pin, that's when you click the joystick, the button on the joystick. These three are for the LED matrix. This one, you just set which pins. These three right here are for the LED matrix. And in the loop, you read the value coming from the joystick, map it to 0 to 180 degrees. Right here I'm printing the value so you can see how the joystick works. Delay 10 seconds, or sorry, 10 milliseconds. The button state, that's when if the joystick's clicked. So here, if the joystick button is not clicked, then it displays nothing on the LED matrix. And if the button is clicked, then it displays this right here. And the way this works, if it's all zeros, then that row is empty. But for everywhere there's a 1, that light that corresponds to the LED matrix is on. So if the button's pressed, then these rows have these certain buttons on, these certain lights on where there's 1s, and delay 50 milliseconds. So for the joystick, right now it's not moving, so it's at 90 degrees. And you could do X and Y axis, but I only have the X axis set up just because I'm controlling one servo. So if I move it all the way up, then it's at 180. If I let it back to the middle, it's back to 90. Move it all the way down, it's at 0. So it pretty much just reads what angle. The reason it's in degrees is so it can control the servo. And here I'm writing the value from the joystick to the servo in this line right here. So that's how the servo knows where to go. So you can see, move up, servo goes up. So the joystick originally prints values between 0 and 1023, but I converted it to 0 to 180 degrees with the servo. And then if I click the joystick, a S pops up on the matrix. And for this one, for that matrix, the way I have it wired up, this is actually this way. So these are actually rows. I just have it hooked straight into the breadboard. So I just had to kind of transpose it on here to make these are actually columns, just the way I have it wired, but they're actually, it's the rows. It's just the way I have it hooked up. For the code for the RFID, here I'm just including the libraries for the scanner, defining the pins on the RFID. This is the button pins, the LED pins. This is the password that you preset, 2314. The user input is the password that the user inputs. The key counter is just a count password entry using the buttons. Here, set all the pins, all the buttons to inputs, all the LEDs to outputs. It's the first scan to start. In the loop, we set the red LED to high. This checks if a key is present, and then this scans, gets the key info. And this makes sure that it's the right key. And if the right key is scanned, then it prompts you to type in the password. LED light comes on, the red light goes off. Right here, this starts the timeout timer using millis. This just resets the user input to 0 for if you put in the wrong password and you have to reset and try the password again. So while the correct password is false, while that's not true, yeah, this just reads the buttons and makes it into a user input array. On button 1, 2, 3, and 4. And during this for loop, this is when it checks for the timeout. See if millis, minus. So this starts another timer, and if that timer minus 0, which is the process start timer. So yeah, here is the timer before the loop, and this is the timer within the loop. So that minus that, if that's more than 10 seconds, then timeout delays for 2 seconds, then it brings you back to the beginning. This is where it compares the user input password to the actual password. If the user input equals the actual password, then access granted, green light on, yellow light off, delays for 6.5 seconds, then brings you back to the beginning. Key counter, that just resets it counts how many buttons you pressed. This is if, so else, so this is if the user input is not equal to the password. It prints access denied. Yellow LED blinks for 3 seconds. Then it displays type in the 4-digit passcode and break. It brings you back to here where you have to input the password again. And there's also a key counter equals 0 in this one to reset the entry. And yep. For this circuit, I have 4 buttons. 1, 2, 3, 4 as the order. They're connected to pins 7, 6, 5, and 4. And the other end is connected to ground. I have 3 LEDs, all connected to 220 ohm resistors, and they're connected to pins 8O, 1, and 2 right here. And the RFID module is connected. So when we start, scan to start, red light comes on, scan the key, yellow light comes on, type in pattern password, and after 10 seconds it should time out and reset. Yep. You can now put the incorrect password, 1111, access denied, 223333, and it timed out on me after 10 seconds. But after the first wrong password, it told me to type in 4-digit passcode, and after I was trying to do the second one, but it timed out. Now for the correct password, scan it, type in pattern password, 2314. Access granted, and a green light comes on, and then after, yep, and then it resets. Back to scan to start.